Hi everyone, by the way, my name is Margus Caspi, and today I will discuss to you about the introduction of sloping agricultural land technology. Sloping agricultural land technology, or SALT, is agri-forestry model farming system first initiated by the Mindanao Baptist Rural Life Center in the southern Philippines to help control soil erosion and increase crop yield. So basically, salt utilizes nitrogen-fixing trees as soil bender, fertilizer generator, and livestock feed source, in which the system also includes annual and perennial diversified food crops grown in the spaces between the hedgerows. So the salt model has been tested both in demonstration plots and farmers' fields. It's because it has been proven to be appropriate for use by typically on some hilly land farmers, so the system can reduce soil erosion and restore moderately degraded hilly lands to a profitable farming system. So next, if we talk about the technology characteristics, it is said that salt is a system in which dense hedgerows of fast-growing perennial nitrogen-fixing tree or shrub species are planted along contour lines, thus creating a living barrier that traps sediments and gradually transform the sloping land to terrace land. So the nitrogen-fixing hedgerows lining the terrace help improve the soil fertility through nitrogen fixation at the roots and incorporation of the hedgerows trimmings into the soil. And also, aside from that, if we talk about the modifications by salt adapters when it comes to technology, so as we all know that Philippine farmers are much like farmers anywhere else in the world. So when presented with a new technology, many immediately begin to change or improve it in order to suit their specific situations and needs. So technology, after all, is to help the farmers. So now this was what happened to salt as it started becoming popular among upland farmers in the Philippines. So the standard of salt farm, as originally recommended by the NBRLC, allocates sloping farmland as follows: about 20% contour hedgerows, so 25% crops and 55% annual crops, which integrated these two options into the basic technology package. So we have the row crop salt system that farmer only plants maize, beans, or any other annual crops, while the other one is what we call permanent crop salt system, that the farmer only plants all the alleys um, with the example like bananas, coffee, and fruit trees or other permanent cash crops. So next, the hedgerows markedly reduce soil erosion and contribute to improving and or maintaining soil fertility by acting as a source of organic matter. So salt has emerged as one of the main approaches used to control soil erosion in mountainous region. So the general salt design described as Salt 1. Salt has been studied in considerable detail at the Cadivar site. So the aim was first to determine whether this method originally developed for tropical areas and could be used in the colder climate of the HKH mid-hills, and second, to to discover the optimum conditions for establishment and use for nitrogen fixing hedgerows rather. So SALT 2 is classified small hydro-livestock land technology as a growth-based agroforestry with a land use of 40% for agriculture is only 20% for forestry and 40% for livestock. So SALT 2 as in a conventional SALT project, hedgerows of different um, nitrogen fixing trees and shrubs are established in the contour lines in which the manure from the animals is utilized as fertilizer for both for food and forage crops. So, SALT 3 Sustainable Agroforest Land Technology is a cropping system in which a farmer can incorporate food production and forestries that can be marketed. So the farmer first develops conventional salt project to produce food for his family and possibly food for livestock. So on the another portion of land, he or she can plant fruit trees such as a rambutan, durian, lanzones that can be marketed. So that can be marketed in between contour lines only. So the plants in hedgerows should be cut and piled around the fruit trees for fertilizer and soil conservation purposes. So in some areas where the soil is too steep for row crops or contour lines may be established for 2 or 3 meters apart and planted with some other suitable hedgerow species. So in between hedgerows, coffee, cacao, calamansi, or other permanent crops could be planted. So nevertheless, the SALT model objectives were to control soil erosion, help restore soil structure and fertility, and be efficient in food crop production, and be applicable to at least 50% rather of hillside farmers, and can be easily duplicated by upland farmers, and be culturally acceptable, and have the small farmer as the focus and food production top priority, and also a workable in a relatively short amount of time and require minimum labor and economically feasible. And that's the end of my discussion, and I hope you learned something. That would be all. Thank you.
Good day everyone, I'm Kusanjin B. Tujanko. My topic is all about benefits to economic, social and environmental development. Contour farming helps check soil erosion and enable moisture retention, thereby enhancing soil productivity. Planting nitrogen-fixing varieties prevailing agroclimatic conditions as well as stress are planted. This results in enhanced soil fertility and recovery of depleted soil nutrients in areas subjected to 10 extensive cultivations. In the long run, this helps in enhanced productivity as well as reduction in chemical fertilizer use in the long run. Planting of crops having different maturity periods. Plantation of seasonal crops, permanent crops like horticulture varieties as well as tree plantations help diversity of income source for farmers as well as create a cushion against the threats of seasonal natural vagaries that may affect income from one of the sources. Labor-intensive activities. The activities related to salt like contour, trenching, plantations, and tending operations, etc. are very labor-intensive as well as requiring some specialized expertise. Thus, with proper government support, salt activities can be able to generate significant local employment and stymie seasonal migration. Improve agricultural techniques that incorporate soil ameliorations and productivity enhance measure at the same time. Respect the traditional practice of the local populace are the key for ensuring food security and counter the vagaries associated with an increasingly unpredictable climate variability associated with global climate change phenomenon. Proper planning and execution of soil can thus result in agricultural productivity increasing manifold. The investment required for implementation of such practice.
Delayed sowing due to shift in season cycle, spreading of pests into new areas affecting the larger number of more vulnerable crops, deterioration of infrastructure of supply of food grains to markets. Thus, the major preserved threats from increasing climate variability to ecologically fragile, mountainous regions are lost of crop production, affecting the primary means of livelihood of the country, increased loss of soil fertility, and increased erosion, which is affected to reduce the already restricted ability of arable land. The increasing incompatibility of traditional cropping cycle with shift in the onset of seasons and the spread of pest to non-affected hetero hitherto non-affected regions. Salt as a technological option is expected to address the issues related to soil and water conservation, enhance soil fertility and consequent crop productivity and crop diversification. Salt is a relevant technological tool that can be adapted to the prevailing in Bhutan in multiple dimensions as discussed above. Financial requirements and cost. The cost of implementing salt will depend on the type of land, especially the land slope and form of salt being implemented. The cost will vary from USD 100 to USD 2005 per hectare. Besides implementation, appropriate funds are required to those purpose of capacity development and technological diffusion as part of NAPA 2009. A budget of USD is 9 million has been envisaged for rainwater harvesting project in Bhutan. That's all. Thank you.
Hi, good day everyone. I am Joshua Kimbrada from BSF2B. My topic is all about climate change adaptation benefits. The traditional upland subsistence cultivation practices are seen as especially vulnerable to the following adverse impacts of climate change. Increasingly extreme variation in climate and weather patterns leading to the growth of flash floods, incessant rains, leading to large-scale soil erosion, landslide, and washing away of topsoil. Rising incidence of pests and diseases due to unseasonal rains and dry spells. A report of National Environmental Commission in partnership with UNEP 2009 lists of the following vulnerabilities faced by agriculture sector: crop yield instability, loss of production and quality, increased risk of extinction of already threatened crop species, traditional crop varieties, loss of soil fertility due to topsoil erosion and runoff, crop yield loss due to unseasonal rains, and that's all. Thank you.